Assalamualaikum warahmatullahi wabarakatuh. Today we will present for the AC three-phase two-pole synchronous motor for the Power Lab 3. So for the member is the Naim Rizuan bin Zaid. Number 2 member is Scovien Olle Lawrence, and number 3 is Muhammad Razin bin Hayadin. Okay, I will present about the equipment layout. So for the first slide, okay, for this first slide, I will explain for the layout install wiring in this activity. So we use three-phase supply that is called as a power meter, and we use 4 parameters to measure the voltage. So the current, the power, and the power factor at the power meter, we must set the selector at the 4 wires because we use red, yellow, blue, and neutral wire. And next, we use a DC meter for voltage for current. This is supply, and digital DC for emitter and voltmeter. For the connection, the red, yellow, blue, and neutral will connected in series to the 4 power meter and the power meter to get the supply directly from three-phase supply. When we turn on the two-phase supply and we increase the voltage, then the power factor red, yellow, and blue, and neutral will supply to the stator to create the electric magnetic force. For two poles configuration, instead the motor assembly panel. So for the supply from the DC supply, and this supply is connected to the DC voltage and current. In this emitter we use analog voltmeter, and emitter we connect in parallel with the digital voltmeter, while for the DC emitter we must connect in series digital emitter. And then the command at the digital emitter will connect to positive side polarity of the carbon brush. Then the negative side we return back to this negative power supply. And then install connection, the red, yellow, and blue will connect together as a common and go back as neutral to the power, to the three-phase supply. Okay, that's all from me. I will pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Naim Rizuan bin Zaid, CE 190070. So today I would like to present the connection for layout data configuration. So the configuration for layout delta is almost the same from the start, but the difference is only the incoming and outgoing supply. So the equipment used in this configuration is three-phase supply, digital power meter, DC supply, DC voltage meter, DC emitter, and the last one is digital DC for emitter and digital DC for voltmeter. So first of all, the connection for red, yellow, blue is connected to the digital power meter, which is red to red, yellow to yellow, blue to blue. And for the connection in digital power meter, it is connected in series, and the output from the power factor is going to the stator. So it creates the EMF in the two-pole three-phase stator. So next, as you can see, the rotor For the DC supply, is connected to the DC voltmeter and also connected to positive carbon brush. So for the, as you can see, for the DC voltage, it is connected in parallel. Meanwhile, for the DC emitter, it is connected in series to get the readings. Okay, next, for the setter layout for star is also the same as the star, but the incoming and outgoing is a bit different from the delta or this is delta, sorry. So for the incoming, red, yellow, blue, so the first one is from the red, this is going to the first pole, which is for number 6 and 7, and it goes to the pole, the second pole, which 1, 12, and go to red outgoing, and it goes to yellow incoming supply. So for the red supply, for the incoming, it goes to the first pole 10, 11, and goes to the second pole for the number 5 and 4, and the outgoing will go to the incoming blue line. For the blue line, it go to the first pole, which is 2 and 3, and it go to another pole 9 and 10, and the blue line is connected to the first line, which is the incoming of red line. So for the voltmeter, it is connected in parallel between red and yellow. For the emitter, it is connected in series in blue line. So next, as you can see, this is DC supply. It is connected to the positive. The ADC is connected to positive carbon brush. Meanwhile, the negative one is connected to the negative carbon brush. So ADC is connected in series. For the VDC is connected to parallel. So that's all from me. So I would like to pass my present to the next presenter.
Okay, hello everyone. Okay, my name is Scovien Olle Lawrence. My metric number is CE1N0077. Okay, now I will present about the graph. Okay, so for the first graph is the calculated horsepower versus load torque. Can you slide? Okay. Okay, so this is the graph, which is the calculated horsepower versus the load torque. So we can see the blue color. The blue color indicate the star connection, and the orange color indicate the delta connection. Okay, from this graph, we can see that the both star and delta connection show the increase as the load increase. And we go to the second graph. Slide back. Slide back. Okay, so for the second graph, which is the AC current, ISC stator in three phase, with the red, yellow, blue versus the load torque. Okay, so this is the, can you slide for the graph? B. Okay. Okay, this is the graph for the star connection, and there are three colors in this graph, with the red color represent the red phase, the orange color will represent the yellow phase, and the blue color will represent the blue phase. And this is the graph for the for star connection. Okay, so this is the graph for the delta connection. And this graph also have the three color, and the three color also same with the graph of the star connection, and the meaning also same with the star connection. And in this graph, we can see that the red color, which the red phase has a higher value, and in this graph of delta connection, we also can see that the red color, which the red phase also has a high value within the three other phase, so that we can conclude that in this both connection, the star connection and the delta connection, the red phase has the higher current volume, and at the same time we can see that the delta connection has the higher value than the star connection. And now I will do the presentation for the last graph, which is the DC current IDC amateur versus the top. And this is the graph first, where we see the color. The blue is indicate the star connection, and the orange color which indicate the delta connection. At this graph, we can see that the star connection has the higher DC column value, and for the delta connection, we can see that the DC current value for the delta connection is nearly constant. So that is for the graph. Okay, that's all from our group. Thank you so much.